Hello, welcome to the FRQ of the day. So today we're going to look at the 2011 number 4. So here we go. Let's see if we can figure this one out. So high cholesterol levels in people can be reduced by exercise, diet, and medication. 20 middle-aged males with cholesterol readings between 220 and 240 milligrams per deciliter of blood were randomly selected from the population of such male patients at a large local hospital. 10 of the 20 males were randomly assigned to Group A, advised on appropriate exercise and diet, and also received a placebo. The other 10 males were assigned to Group B, received the same advice on appropriate exercise and diet, but received a drug intended to reduce the cholesterol instead of a placebo. After 3 months, post-treatment cholesterol readings were taken for all 20 males and compared to pre-treatment cholesterol readings. The tables below give the reduction in cholesterol level, pre-treatment reading minus post-treatment reading, for each male in the study. So here's the ones for Group A. That's the reduction in cholesterol level in Group A, and here's for Group B, and they give the mean and standard deviations. And so the question is, do the data provide convincing evidence at alpha is equal to 0.01 level that the cholesterol drug is effective in producing a reduction in mean cholesterol level beyond that produced by exercise and diet? And so if you want to pause the video and give this a shot, that would be great. Okay, so this one here is a pretty stock two sample t-test where they actually give us the data. You know, when it says the data provide convincing evidence, in essence that's asking for a hypothesis test. And certainly when they give you the alpha value, in other words, you got to find a p-value. Whenever you do that, you got to follow the THAME acronym. All right, and so if the p-value is below 0.01, we reject our null hypothesis. If it's above 0.01, we would not reject the null hypothesis. So the first thing is the name, and certainly this is definitely quantitative data, and so we're dealing with means here, and so that is a T. And so here we go. So the first thing is the T, state what you're doing, the type of inference, and so you'd say I'll do a two sample t-test for means, and so that is that, and then our hypotheses. And you know that your null hypothesis is always going to be that the two means are equal, where mu sub p is the mean reduction in cholesterol level for male patients like these who take a placebo, and mu sub d is for those that take the drug. And realizing, you know, and it says up here, you know, is the drug effective? Well, if it's effective, then the drug is going to have more of a reduction in cholesterol level. So in other words, we're expecting it to be positive. We know that, notice that the drug has a mean reduction or an average reduction of 16.4, and the placebo had an average reduction of 10.2. So it seems that it works better, but the question is it statistically significantly better? Okay, that appears to be maybe a pretty good difference, but you know our sample sizes are only 10, and that's pretty small. So anyway, but before we find the P, so there's our T, there's our hypotheses, and make sure to define your variables there. And then of course we sin, and in this case it's I sin. Now this one, the way this one's worded is a little bit unusual, because they were randomly selected from this hospital. And so if we're only trying to generalize about this hospital, we've got a good random sample. But then down here, it's making it seem like in general, not just the males in this hospital, and it's just males, by the way. So we randomly selected males from the hospital, so we can really only infer or generalize about males in this hospital. But then it appears to be talking about in general, is effective in reducing mean cholesterol levels beyond. So, but now we definitely had random assignment to treatments here. It says they were randomly assigned to Group A and to Group B. So anyway, all right, so in regards to your sinning, you need to say, well, it says random selection and random assignment, so random conditions met. So it says that the patients were randomly assigned to groups and randomly selected from this hospital, thus independent random conditions met. Remember the two sample things, you always have to say independent. Now, in regards to the rubric, they just said randomly assigned, okay? And the reason is because it appears they appear to not just generalizing about the hospital, but about all people in general. And in that case, you wouldn't have random selection. So the rubric, there was some there was some leeway in what you had to say there. But remember, the 2 samples got to be independent random. Our population size has to be at least 10 times the sample size. Now, in this case, if you're talking about just people in general, we did not have random selection from our entire population of all adults in the United States. Okay, so you didn't have to check that condition. But if you're generalizing about the hospital, and then you say there has to be at least 200 patients like these for our population size, at least 10 times our sample size. If you had random selection without replacement, which that's going to be the case if you're just talking about the hospital. So I realize that's a bit confusing, but anyway, the rubric took that into account, so there's some leeway there. The other thing is normality. Of course, normality in regards to means, are your sample sizes bigger than 30? They're not. Does it say in the problem things vary approximately normally? It doesn't. So you graph the sample data, and as long as you don't have outliers or strong skewness, you say normality is reasonable. And that's what happens here. You would say that the sample graphs show no outliers, no strong skewness, or normality is reasonable. You can make the case maybe that looks like an outlier, but it's not. So anyway, so then you would do your mechanics. And now let me say this about this year's exam. This sort of thing is going to be emphasized. You know, being able to state your hypotheses, being able to check your conditions like this, and with your ISIN, that's going to be emphasized. Actually finding a test statistic p-value, it could happen, but what's going to be more likely to happen is they're going to have you do this stuff up here or to interpret the p-value. But, you know, there's our formula. We've done that a few times off of your formula sheet, and I don't think that's going to be emphasized. There's your degrees of freedom, which I got off my calculator, and p-value. And like I said, more than likely this will be given to you. But, you know, you do need to be able to use your calculator to do this. So what we'll do is we'll put, so we're given the data, so we'll put the data in list 1 and list 2. So we'll go stat and edit. So in list 1, I put for the group A, which is the placebo group, and group B is the drug group. Now put that in list 2. And so then we'll do the test. So we go stat, and then we go test, and we go down to 2 sample t-test, the 4th option there. And so we hit enter, and we're using data, so I hit enter on data, list 1 and list 2. Our alternative is less than for, as we talked about a minute ago, we want to see if the drug works better, which means there's going to be more reduction. So the alternative is less than. We always say no to pooled in regards to if our calculator asks us that, and we go calculate. And so there's our test statistic p-value and degrees of freedom. And those are the 3 numbers you have to write down in regards to a t-test. And so there's our summary stats, by the way. And so then this p-value is greater than our alpha, which is 0.01 in this case. So I failed to reject the null. There is not convincing evidence that, and then you restate the alternative in context. So there is not convincing evidence that the mean reduction in cholesterol for patients like these who take a placebo is less than the mean for these that take the drug. And this, I feel this is going to be in your exam. Being able to do this, being able to do this stuff up here, and this stuff will probably be given to you. And the other thing is we've talked about, they could ask you to interpret your p-value. This is drawing a conclusion from a p-value. Okay, to interpret your p-value means state it as a probability, which means you would say this. Well, the p-value is the probability of that if the null is true. In other words, if there's no difference in the drug and the placebo, the probability we would get sample values this different is 0.06191. And so, in other words, there's about a 6% chance. So it's sort of unlikely, but it's not statistically significant. It's sort of a bit of a borderline case, and it's certainly bigger than 0.01. So now, and then the next question we ask, well, you know, what sort of error could you have committed? Well, this could have been type 2 error. You know, we failed to reject the null, so it could be type 2 error, and we could be lacking in power. And then it could ask, well, what could you do to increase power? That would be increase these numbers here, our sample size, increase our N, and that would increase our power. So, or you could, in essence, increase your alpha value. If you increase your alpha value here to 10%, you would reject the null. But there's trade-offs in that regard because you're increasing type 1 error, right? So anyway, that's it. If you have any questions about any of this, please let me know. But hope you have a wonderful day. Thanks for stopping by.